My name is Patrice Brissette. I'm Distinguished Engineer at Cisco. I'm also the chair for the SONiC Routing Workgroup. So people, you should also come to see us at those meetings to help the community to work on routing aspect of the SONiC. So today we're going to be talking about the multi-site. We call it EVPN Multi-Site because it's sponsored by EVPN, but it's really a multi-site concept that I want to bring to your attention. We're going to go through architecture and concept flows, etc. So, all right. So whenever you have data center and you want to interconnect them, obviously you will do DCI. We talked like it's nothing is new here. But what is kind of new is we are bringing multi-site to SONiC. But not only the multi-site that makes, that allow you to interconnect data center, but also to make it like slightly differently in your brain. And what I want to put in your brain is something more like this, where we are bringing the concept of domains. So basically, you can have multiple pods which gonna build your data center, but instead of, let's say you want to extend pod A, or you want to extend the data center, which is just A at the beginning, most of the people will tell you, oh, just put more leaf and more spine, and then you're going to grow your data center. It's one way to do that. But another way that you can do it is say, okay, I'm going to have a domain for my yellow data center. I'm going to replicate the same thing in a green way, like for the green portion, and just going to extend that with another site at the top. So you have three sites together, and then it will extend this into a single DC. So that allows you a lot of things. Where first of all, you know, with SONiC, sometimes scalability is a problem, failure is a problem, recovery. You know, like we are getting there, but we are not there yet. So therefore, if you start supporting the concept of those multiple domains, which are more kind of Lego blocks, then all your pieces are kind of constrained to themselves. So if you look at in the pod A, like how many resources do you need to run this? Not much. Then you look at B, how many resources do you need to run it? Well, not much neither, right? You can also like apply policy at your spine. You don't need, you can do anything about your route. You don't need to expose everything to everyone. You can put some security stuff there. You can even like switch underlay or technology. I can have, for people who know Cisco, an ACI data center, which is the pod A, I can extend it with SONiC now very easily. Because I will just put a domain at the top, domain A, and I'll create more pods, but I can use SONiC, I can use whatever I want after that. So the concept of multi-site allows you to do really Lego blocks, not only just a pure DCI functionality, which is, in my opinion, quite boring because nothing is happening there. Okay? So yeah, so why do you do that? Well, I just mentioned about this, right? So therefore, I think what is really important is all about the separation. So when you look back at this type of topology, it means that I can run easily an IPv6 data center or pod A. I can have a pod B with IPv4. I can make that together by having something uniform in the multi-site domain A. So therefore, I can do anything, right? Because on the spine, which is my border gateway, I will do full termination and full decap of the traffic within the DC and full re-encap into a different domain. So now it means that if I start supporting domains, I can support tons of domains. Like on those two spines on the left, on the orange, I can have yet another domains also connected, talking to maybe another set of pods. So now the picture can become like 3D if you want to, because it's just domains that you're connecting together. So the concept is quite simple to make that possible. Is you will need, first of all, VTEPs. Like if you look at VXLAN, because that's what we have on SONiC mainly for data center. We do have SRv6 as well, but it's coming. But which is most deployed in enterprise and in our customer is we have the VXLAN. So you will have a VTEP facing your data center and a VTEP facing your WAN. Well, you say, what is the domain? Yeah, but one domain is the DC, one domain is the WAN. I can have yet another domain hooked up to these two. I can have 3 domains together, 4 domains. It doesn't really matter. That's really how we build it for SONiC. So also, because people are, because building network is very expensive, whenever you look at your border gateway, remember like the 2 spines I was showing previously in the picture, right? These guys, right? The 2 border gateways right there. So many customers will look at it and say, okay, but why would I spend money just for doing DCI? I mean, you're in an enterprise, we are buying SONiC, we want to save costs. So meaning that I should be able also to use the spine as leaf to connect host as well. So as soon as you do that, then you're getting into more complex, and this is what I'm showing here, where you will need all the multi-homing capability that EVPN is bringing to you. So therefore, what you will be doing is very simple. You will say, okay, this pair of node, we're going to put an ESI on it. This is just like, it looks like 1. And that ESI will allow me to filter my L2 traffic, right, to reduce my BOM, etc. But also is if I'm starting to connect directly connected host to a single border gateway or to both, because my host can also be multi-home, then this logic will start kicking in. So that's what we are also bringing to FRRouting and SONiC. So therefore, you allow yourself that, oh, my border gateway can be a border leaf, it can be a leaf, or just DCI, depending on what you're connecting and how you configure the beast, basically. So if you look at really what this is, it's pretty much very standard, right? You will have your L2 bridge domain for your L2 connectivity. You have the DC domain, WAN domain. I could add more, by the way. I already said that. I could have attachment circuit for my locally connected host at the border gateway. All of that goes through your single gateway out of it, because you want to, if I have an L2 service, I want to get to L3. And then you have your domain that you're sticking up at the top for your L3 connectivity. So one of the key pieces also is that whenever you start doing this type of work, is that you need to normalize all your VNI within a domain. So if you start doing, because see, I can have a DC that already exists that use VNI values. It's already there, it's been there for a while, and you don't want really to touch it. I want to grow it with more pods, as I was showing in the initial picture. But then, what is the value I'm going to use for the VNI? Because maybe what I'm going to extend has already different VNI. So therefore, each time you create a new domain, you want to normalize it. You want to have a value that will stitch them up, which is not probably a value that others are using. So therefore, it allows you to grow. Because, see, history will bring you pain on that and say, oh, shit, I thought to use this one, but this has been used by this guy. And then you won't be able to match up any of those values. So therefore, the solution is, again, as I said, here in this example, is everything is getting normalized to 1,000. Super simple. You connect all of them, and you keep moving. So you don't need to bother. But some also will do, no, but it's kind of difficult for us to do. But on the SONiC side, we decided to go with the first approach. This approach will work as well. It's downstream assigned. It's more like what MPLS was doing. So give me your VNI value, I'm going to be using it. But if you start doing this, then it will use a lot of resource. Because I need to know for each remote endpoint what type of VNI value I need to use. So the replication and etc., you burn resource like crazy. So if you want to avoid that, you're going back to this. It's beautiful. So basically, this is the two choices. Both will work on SONiC. We are supporting both. But the preference is on the left side of this picture. We do also bring the all about mobility as well. We don't have a choice, right? So if I have pods, I want to stretch, or if I have a pods that I want to stretch into a bigger data center, obviously if I have mobility happening across my pods, I need to be able to support that. We do support it. We do support it also via, let's say you have a customer which is purely like an IP connection to your data center via a border leaf, and he's doing VRF light peering with you. obviously, if he's going across, if my VM is moving across the pods, he still needs to have connectivity. All of that have been thought. We are supporting all of those interactions for mobility. And it's all standard-based. So if you look at the VPN RFCs, I mean, it's all there. That's what we brought completely to the SONiC and FRRouting stack. So for the flow, it's very, very simple. As I mentioned, remember I said there's a VTEP facing each domains. So therefore, what you do, you're just switching your source IP. So it's kind of boring, right? Nothing is happening. You keep switching until you reach. This is for L2. For the BOM, very similar, but you will have the capability with the Ethernet segment to filter out your redundant and duplicate and avoid loops. So all of that will happen also at the border gateway because you're going to set up an IESI. For L3, again, exactly the same thing. The only difference here, you will see that your VNI is also changing. Why? Because I mentioned previously that you needed to normalize it. We always normalize it. So to make sure that however your domains will grow from domains to domains, you're not getting stuck with a value that you cannot handle. So you always make it change. So for the isolation, this one is quite interesting because, you know, like as soon as you start connecting, like having like hosts connected at your border gateway, it's becoming quite problematic to reach it. So let's say here in this example that on your WAN side, connectivity is no longer reaching the border gateway 2, so to reach your host. What are you going to do? There are a couple of things that here to put in place before we explain. Most of them, what I'm seeing today is the customer will have a data center, let's say with IPv6 address, and the one will be IPv4, or vice versa. It's quite, I don't see all the time V6, V6, or V4, V4. So that's the first thing. So therefore, you need to handle double stack. So now if I need to be able to keep the reachability with a dual stack IP, what do I do? Well, you can start leaking IP address from one side to the other side, start supporting dual stack everywhere, which is not always possible. Some people will say, yeah, you can do it. Some people will say, I hate it. And some people will say, I cannot. So therefore, one way to do this is also to put kind of just a peering between the two border gateways. Some people say, yeah, but now you're burning something. Yes, you may burn something. Right? But if you start doing that, at least I can guarantee you some connectivity. So that's one way to do this. The other way that people will tell me, but say, hey, but Patrice, if when I look at this picture, I still have reachability through my leaf. I can use my data center side to come back to the border gateway. It's possible. But if you look at all the RFC that we have in EVPN today, it is not possible. There's no way to do that. So therefore, for now, you can either do route leaking, or you can just use your own delay, or put a peering connection between the two, and the job will be done for you. However, oops, sorry. So that was one. So the other one is now on the flip side, you have the same problem is there's a failure within the DC. And now what do you do? We just talked about it, right? So therefore, I mean, you can flip it in all the side, but then you're kind of stuck. So what we are coming out of Cisco, and you will see it very soon, we are coming out with a new way, an enhanced way, and that will give you something like that. And I put this table here just because I'm a geek and I like the table. So don't try to understand it. It's pretty bad. But what that table will tell you is, say, from now on, we are adding explicit rules to help all the silicons or ASIC that we like, Broadcom, Silicon One, everything that exists, where we will just start performing egress filtering. And then you don't need to have that direct peering because new rules will be applied to a VPN to allow you to bounce back and within the DC or within the one to achieve all the connection that you're not having. So basically, inside your SDK or your ASIC, that's one of those tables like that you will need to do. It works like a charm. Believe me, we tested like at length. So, but for that, we soon in ITF, we'll position our draft. We'll explain all the details about how this is working. So what were the challenge? There was a lot of challenge. Actually, it was not an easy project. And also be aware that everything that we do at Cisco is getting upstream. Okay, it's an in-house rule. So last year I was talking about EVPN Multi-Site. We are getting upstream right now. This is going to get upstream right after this work. Once EVPN Multi-Site is there, FRRouting, SONiC will get all of this. So you will be available to the community. So one of the first things is the domain concept. Why domain concept is important is, again, is give you flexibility. Okay, if you look at, I work on iOS XR for many years, and we did a bad job there because we were just like stitching up WAN and DC. So we're kind of stuck with the concept of a keyword WAN and the keyword of DC, and then honestly, it's still painful. So therefore, the approach we say, okay, let's start with the forwarding. So whenever you're setting up your forwarding, remember I was showing the picture where you have the VRF and the bridge domain that you're stitching the L2VNI, or you're connecting the L2VNI together. That forwarding aspect, you will say, I'm connecting domain A with domain B. I'm not connecting a WAN or something that faces somebody, and I'm not connecting I'm just connecting the concept of a domain. Because you know, like the architecture with SONiC is you have this whole SONiC things at the bottom, right, with the Arc agent and etc. Then you have the Linux kernel, and then you have our friend FRRouting. So now I need to go then after in BGP setting up my connection. Well, then how do I know what I'm connecting with who? You know, because my forwarding is one way, and so that's why we use the concept of domains. So in SONiC, we will set up the domains based on a stream, which is a domain name. In FRRouting, use the same domain name. Say, oh, I'm peering on that domain A, and this is how they glue together. So it's very simple, it's very elegant. So whenever you do, you're looking at your config, you understand super easily what this is about, and you can give any name. It doesn't need to be DC and WAN. You can do whatever you want. But it's just because of those strings that goes together, and by netlinks messages and all of that, it works like, it works like very, very easily because of that. But it took a while to figure this out and make it like easy, because it's one of our main things that we want to do. The other thing also that was challenging is all about the Route Type 2 and Route Type 5. Because if you're doing, let's say, multi-site just for L2, okay, then you need to prune the MAC IP. I don't want to start like doing multi-site for L3 if I just have an L2 connection, because this one will die. So then you need a new policy that you need to add to BGP. So now we ran a bunch of use cases like that you just have IP, you just have the L2, you have the mix of both, and sometimes you need the mobility, sometimes you don't need the mobility. So then when are you reoriginating the route, when you don't? So anyway, everything has been explained, but that was one of the pieces that was quite strange to settle. And then, okay, per domain ingress replication. So we have obviously new development there because you need to replicate to 2 different domains. So that was not existing. The fact also that we are supporting multiple domains and we are supporting multiple VTEPs, it was all new, because today in SONiC and in FRRouting, you cannot support multiple VTEPs or multiple VNI stitching on the same bridge. It is not there. If people say yes, it exists, upstream your code because it's not there. So therefore, we need to bring the concept of the source VTEP as well. So to define each tunnel. A tunnel before was defined just by a destination IP. Now it's a source plus destination because of the domain again. And you want to put it on the bridge or you want to put it on the VRF. So that was the FRRouting challenge. Now, if you look at SONiC, it's very, very similar. Okay. And also, I will tell you the most complicated aspect was that table I show you for the geek, right? This wonderful table I was showing you here took a while to figure out, okay? It took a while to really think about it. Now, the thing about this also that you need to understand is whenever your border gateway start peering together with this ESI, right? Because, well, where do you create your tunnel between? You create it on the north or you create it on the south? On what domain are you allowing the traffic to go? Because if you allow both, you're going to start looping. So it's super fun. So therefore, you need to figure out which one. But then if you have a failure on one side, you switch over the other tunnel. So all of that will be explained in the draft because you don't want to, okay? So yeah, so that was the other thing. So basically, from this, what I want you to take on that, right? Okay, DCI, you know DCI has been there forever. But your DCI, you can start using it as a border leaf. You can start using it as a border gateway. You can start doing also like connected hosts there with multi-homing. All of that is coming to SONiC. All of that is based on RFC and standard. Okay, so there's nothing special about it other than what you can read on the web. So also, the one I want to bring to your attention is, remember, when I say we are stitching domains, is because I see it as a Lego block. If I have a small data center of 4 leaf to spine that I want to grow, I can keep adding leaves. Or I can create a cut and paste on of that small DC to another DC, make it another one on the top, and they are all stitched together via the multi-site technology. And for SONiC, it's really nice because then you're not going, again, as I said before, your scalability is super important. Sometimes you don't have the resource, right? Your ASIC are very cheap, and we are running on cheap hardware with SONiC most of the time. So therefore, how can I scale? It's a very nice way to scale, right? Or if I have a failure, instead of tearing down your entire DC, you're tearing down just a part of your DC, like a pods, like small cluster of your DC, which is even better. So think about it whenever you're building your DC, because that technology can help you out quite a lot. This is the reading where we started, and there will be one more soon coming to your theater near you. Okay? Call for action. This is the HLD. It's already public. You can read it. You can go through it. I presented at the SONiC Routing Workgroup a couple of months ago. Once we are, C2605 is getting ready as we speak. We are providing VXLAN multi-homing in 2605. As soon as this is closed, this is our next step. I will need your help to review the code, to review the HLD, to speak up, to give me a hard time, and I will be pleased. Okay, thank you. Questions?
How do you assign the normalized VNI? Configuration?
Config based, that's it.
And when you do multi-homing, you need to make them also VNI. Or is it not required?
No, it doesn't matter. That's why you have it normalized. So on your DC side, multi-homing or not, doesn't matter. DC will have a VNI. The other domain will have another VNI. And that's it. Very simple. Any other questions? 2 minutes?
2 minutes, 5 questions.
No tough questions? Cool. Thank you.
I really appreciate it.